A generic salt, AB3, has a molar mass of 259 grams per mole and a solubility of 6.70 grams per liter at 25 degrees Celsius. What is the Ksp of the salt at 25 degrees Celsius? So below we have a reaction that's given. AB3 solid reacts, and remember this is in water with all of these, and will dissolve into A3 plus aqueous and 3B minus aqueous. Okay, so this is generic salt that has some cation that has a +3 charge and an anion with a minus. And to balance it, we need 3 of the anions. Okay, now this is related, this reaction, whenever you have a solid that's dissolving, is a Ksp reaction. And Ksp is going to equal the products over the reactants. And remember, the products over reactants that can go in here are only aqueous or gases. Okay, so we have A3 plus concentration and B minus the concentration, and that is cubed. So in order to find the Ksp of the salt, we need to find the concentration of A3 plus and the concentration of B minus at equilibrium. Okay, and remember that concentration is moles per liter of solution. So moles of A3 plus over liters of solution and moles of B minus over liters of solution. So now the way that I would go about doing this is it says this generic salt has a molar mass and a solubility. Okay, so this solubility right here tells me how much is going to dissolve in water. Okay, so because this tells me how much is going to dissolve, I can figure out what the molarity is of AB3 using the molar mass. So first step is find the molarity of AB3 using the solubility and the molar mass. Next, I'm going to use that to find the concentration of A3 plus and to find the concentration of B minus. Okay, and then the third step is I'm going to find Ksp. Okay, and I'm going to use this equation right there to do that. Okay, so first up, find the molarity or the concentration of AB3 using those numbers. Okay, so if I have a solubility of 6.70 grams of AB3 over liters of solution, okay, and we can think of that as 1 liter of solution. Next, we're going to use the molar mass. I have grams at the top, so I need grams at the bottom, so this is 259 grams of AB3 over 1 mole of AB3. Okay, so my grams are going to cancel with my grams, and I'm left with moles per liter. And the answer I get is 0.0258 moles of AB3 divided by 1 liter of solution. Okay, so there's my first step. My second step is I'm going to use this number here to find the concentration of A3 plus, right? And that's going to be moles of A3 plus over liters of solution. So to do that, I'm going to use the balanced equation, and I'm actually just going to go from, we'll go with purple, I'm going to go from this number right here. So if I look at the balanced chemical equation, I have 1 mole of AB3 equals 1 mole of A3 plus. Okay, moles of AB3 are going to cancel, and I'm left with moles of A3 plus, and so this number right here equals 0.0258 A3 plus divided by 1 liter of solution. Okay, next step. Step number 3 is to find the concentration of B minus. Okay, so to do that, I can either start right here with moles of A plus, or I can start with moles of AB3. Since this is here, we'll just start with this one, okay? So what I'm gonna do here is I'm gonna take A3 plus. I know 1 mole of A3 plus equals 3 moles of B minus. Moles of A3 plus cancel, and I get 0.0258 times 3 moles gives me 0.0774 moles of B minus divided by liters of solution. Okay, my last step, number 4, is to find the Ksp. Okay, so Ksp is going to equal the concentration of A3 plus times the concentration of B minus to the third. So if we look back through our numbers, this number right here is the concentration of A3 plus. So maybe I'll just put like an A right here. So that's this concentration. And this concentration right here goes in there. Okay, so Ksp is going to equal my concentration of A3 plus and here, just for shorthand, I put molar instead of moles per liter, but it's the same thing, it's molarity, times the concentration of B, 0.0774 molar B minus, and that number is cubed. So when I put this on my calculator, I get 1.20 times 10 to the minus 5. And remember that Ksp number is unitless. So that tells us how much of this AB3 is going to dissolve into the ions.